The next one, which is also a classic, is the selecting. You're selecting, you're choosing. How many ways can you choose? Okay, selecting or choosing, teams, groups, hands of cards, where order doesn't matter, or you have no positions mentioned. Okay, so that's when you want to go combinations. And I would say this, I would add this, you're taking more than one at a time. You're selecting more than one at a time, then it's combinations. Okay? Again, we're going back and forth between most of these examples right now are just reviewing number of ways. We can easily turn this into a probability. Okay? So let's imagine there's 4 dance and 8 band. I'm kind of running out of original ideas here, I know that, but it still illustrates the point. 4 dance, 8 band, 12 total we're talking here. And by the way, there could be 4 dance, 8 band, and 2 choir, right? That could also be there. It could be 3 categories or more. It wouldn't change the way we approach this in general. So if you just want to make groups of 6, like how many groups of 6 are possible? How many teams? They're supposed to represent Sisler, let's say, at an event. So obviously you just add up, it's 12 to 6, okay? That would be your universal. If there's a probability following this, this is what the denominator would be for every single question that involves a probability in this case. Next, groups with 3 band students. Notice, this is implying exactly 3 band students. It's not saying at least, it's not saying 3 or more, or up to 3, it doesn't say that. It doesn't say at most, it says 3. So that's just exactly 3. And so we would just go from the 8 band students, we choose 3. So we've picked 3 already, but remember, we need a group of 6. So that means that from the 4 dance students, we're going to have to choose another 3 to complete our 6. So we've got 12 and 6. It kind of needs to be there all the time. See how there's 12 and 6? So that kind of is a pattern. So this is how you would, this would be your NA. So if you wanted a probability of this happening, of there being 3 band students, it's 8 choose 3, 4 choose 3, over 12 choose 6. Okay, that is this one over here. I'm not going to solve because it's right now a matter of just understanding the concept, okay? Groups, how many groups with at least 1 dance student could there be? At least 1. That is a key word that I want you to understand. So what we're going to do here, if you want at least 1 dance student, we're going to then say, well, let's get rid of all the instances where you have no dance students participating or part of the group. So we take our total, we subtract from the 4 dance students, choose none. From the 8 band students, choose all 6. So this is basically saying these groups do not have any dance students in them. We're subtracting them from the total. And so that is what is left over. So if you wanted the probability of this happening, it's 12 choose 6 minus 4 choose 0, 8 choose 6 over 12 choose 6. Okay, so that's still my universal here. And remember, again, 4 and 8, what does that add up to? 12. That's my total number of participants. 0 and 6 adds up to the group of 6 that I'm after. So that's something that you want to check consistently. Same with hands of cards, right? So let's say you wanted to, let's go up here real quick. You wanted a hand of card where you have 3 aces. Okay, how would this change? Out of the 4 aces, we're going to choose 3. And how many are left? Because you need to make sure these 2 numbers add up to 52 if it's cards, right? There's 48, and from the 48, we're going to choose another 3 to have our hand of 6 altogether. If we were making hands of 6, you would still want to make sure that the subgroups add up to that big hand that you're trying to come up with. Okay, so that's your deck of cards. or not deck of cards only, but it has to do with combinations, right?